Hello, Hare Krishna, and welcome back to the Atma Paradigm. We continue with part two of our webinar series on matter and reality. This is session part two, number 7, which deals with intention, moving matter. So we're going to look at the theory and evidence that consciousness has the ability and actually does affect the properties of physical systems. So let's have a little look at last week and where we got to. Previously on the Atma Paradigm, humans share an instinctive belief in free will. That's part of our nature. And when we talk about will, we're saying that which emanates from me at my deepest level, the state of being, which we call the conscious self. So we defined last week will as the wish to vary the content of my experiences. And we said that when conscious will is first directed towards physicality, and particularly to the persona self, the actor on the stage of awareness, we call that initial expression of will chittam. And just to give you an example, we've got a glove puppet here. Now, consciousness likes to shine its light on something. So here we have our girl who's shining her conscious intention on this glove puppet. And you can kind of think of that as how consciousness interacts with the persona concept of ourself, or indeed how it interacts with the physical self of our body. It's like a hand in a glove puppet. And Vedanta philosophy explains that the nature of consciousness is to shine its light on something beyond itself. So we see our physical form or the mental concept we have. We see that and we absorb ourselves in that. So even though my hand has not actually changed in any way, it has not become the puppet, my consciousness is now thinking about my hand in terms of this covering that is there. And Vedanta explains that consciousness absorbs itself in 3 aspects of information about the object: its category, its qualities, and its activities. So now I'm thinking about the puppet's category. If it's on my hand, I'm thinking, oh, its category is it's a bird. In this case, subcategory, an owl. Its qualities, well, it's brown and white, and it's got big, cute eyes. And its actions, well, it can flap its arms, and it can nod its head. Yes, that's all happening through my intent in my hand, making it work. But now my conscious interest is absorbed in looking at what this bird is doing on my hand. And in many ways, that's a very good analogy for how consciousness becomes absorbed in the selfhood of the persona and our interactions within this material world. So this is the basic connection between consciousness and the mental world, and its absorption in the information about category, qualities, and activities. And the Atma's expression of will towards identifying with the categories, qualities, and actions of our mind and body is called chittam. So just wanted to kind of clarify that particular phrase. Now, also last week, we talked that the Atma's expression of will towards identifying these as chittam produces the agenda of the persona. And we're using this particular diagram to help us. And that this agenda of the persona, this idea of who I am and what I want out of life, that starts to be developed within the cognitive functions as an overall term we're giving called intention. So together, the cognitive functions generate intention in order to fulfill the agenda. And then an intention is further developed by the mind and intelligence into a whole range of mental outputs. And we've labeled these ideas, thoughts, decisions, desires, plans, strategies, etc. So this is the flow of information from the will through chittam, agenda, intention, to producing ideas and desires. But it's a bit like Chinese whispers. Things sometimes get lost along the way. It's like the old joke from the First World War. They were trying to pass a message along the line of the trenches, and they said, "Send reinforcements, we're going to advance." But by the time it got to the end, it was "Send 3 and 4pence, that's old money, we're going to a dance." So it's a bit like that. Sometimes the desires and ideas that come out of our mind, may not seem to be fully representative of what we actually might hope for ourselves. So we said, we have much more free will than we think we have, but perhaps we use much less free will than we think we do. Now, some of our mental output is purely for internal purposes, if you like. We kind of have fantasies and muse on ideas. We have dreams of plans of big holidays or things I'm going to achieve. I'm going to climb Mount Everest. We have no real inclination to actually realize them. They're just, we enjoy just thinking about those things, but without having to kind of worry about how would I really make it happen. They're just fun. But other ideas and desires are intended for action or manifestation. We do expect to realize them. You know, whether it's the simple activities in getting up in the morning, I want a cup of tea. That's a simple desire I intend to put into action very quickly. So these are the ones we need to consider for our model, and this is what we're going to talk about today. So our minds can generate intention in the form of ideas and desires, and the question is, how do they affect things? How do thoughts make things happen? This is a very serious question. What is the ability of mental stuff, thoughts and desires? What's its ability to affect neural processes that ultimately manifest in the physical body doing stuff? So there's three questions to be answered. Do our thoughts and desires have agency? How do non-neural thoughts give rise to biochemical processes? And if non-neural thoughts are changing biochemical processes, how is that happening if it is not a contravention of physics or the conservation of energy? And these are the standard questions that philosophers and scientists continue to debate to the present day. I think the Atma Paradigm has a particular approach on this. Now, I could just give you an answer using our Sankhya model, you know, and I could explain that in volition, our intention, as shown in this diagram, generates mental icons like ideas and desires, and these mental forms of information are encoded as proto-physical information, which you remember from our old chart, that then changes and manifests physical properties in action. And we will look at how all of that works next week. And you'll see that that actual system opens up some incredible potential for doing things in a way that we might not have expressed before. But before I go and give you the Sankhya and the Vedanta picture, I'd actually like to show you we can answer these questions using physics and neuroscience. So thoughts and actions, they're related. We know that. We know that somehow or other our thoughts connected with the stuff we do. So example, we're sitting down waiting for the train to come and it arrives. This is not the one you want. This one's going to Uxbridge. No, not the one I want. Leave it alone. The next one coming in, I see it. This is the one that's taking me to my destination. Therefore, I decide I am going to get up, get on the train. So thoughts and actions are always interacting in this way. But how can this work if the mind is non-physical, non-neural, and it needs to manipulate a physical, biological object, the body? It's a complicated process. I'm going to take you through it in 5 steps. And the reason I'm doing that, and I want to let you know the steps I'm taking, is because some of them are a little complex and detailed, and especially if you're not familiar with the physics involved. But I'm going to try and explain it faithfully to the physics, but as simply and as straightforwardly as I can. And I'd suggest don't worry if you can't retain all the details of a particular section. The important thing is to appreciate or to understand the conclusion that each point is intended to establish so that we can move on to the next one. So these 5 are how intention makes things happen. Then we're going to look at intention and quantum physics. Then we're going to look at quantum-based biology. Then we're going to look at non-neural intention and brain activity. And then how small intention effects can be magnified. So those are the 5 things and 5 steps I'm going to take you through. Let's start off. How intention makes things happen. Well, kind of you know this already. Here is my print screen. And this is a document I wanted to print. How do I make it happen? Well, I have an intention. I want to see a physical manifestation of this digital data. This may be, it's in the ether as data, but I want it to be produced on a piece of paper. So I need my printer, this physical system of the printer to actually do something. But all I need to do to exert my will on this is to click on the print button, and immediately it churns into action, and the document is being printed. Now, I'm not supplying the energy for the printer to work. That already exists. It's plugged in. It's switched on. It's got its own energy supply. It's complete like that. I'm just sending a message to it to use that energy that it's got to print my document. So this gives us an idea of how my will and intention is delivered to the machine and gets it to do something. And it really doesn't take much physical effort to make that happen. Just a tiny movement of my finger on the mouse. That's all it's needed. And this machine jumps into action, and it could be printing out a whole bookload of documents just with that click. But still, you could say, it required some physical energy to do it. So there must be some contact where some physical effort is needed to get the physical machine to work. However, the principle here is that volition can input information into a system to get it to do something, and that input can be a very small physical movement. Now, the question really is there a way of inputting intentional information without any physical effort or energy or physical energy being involved? And the answer to that is yes. And that introduces us to our second point. And it brings us into the wonderful world of quantum physics. Now, it's a complex thing, and it's often said that anyone who thinks they understand quantum physics, cannot appreciate it. However, what I intend to show in this section is that intention can vary the output of quantum-based systems without physical input. Now, in order to establish that, we're going to look at quantum physics, and particularly the topics of the nature of light. We're going to look at the double slit experiment, one of the most fundamental experiment involved, showing the issues behind quantum physics. And we're going to look at the significance of the results from that experiment on the nature of reality. And then we're going to look at experiments that were aimed to explore how or if intention affects quantum processes and physical systems. So this is our little point 2 section, intention and quantum physics. Let's start with light. Follow me with this as I read it. Light is Now, what was the word that came to you in this one? Did you say light is a wave? Did you say light is a particle? Because the question of whether light is a wave or a particle, of course, exercised many physicists, particularly during the 18th century. And I remember even discussing it at school. It wasn't that long ago, but still we were discussing it. And this was settled in 1801 by a gentleman called Thomas Young. Now, he based it on this principle, that here we see waves coming in from the sea. They are hitting the rocks, but there's gaps in the rocks. And that allows the waves from the outside to create circular ripples on the inside of this pool. And then they start to mix together. And when two waves start mixing together, bits of them start cancelling or reinforcing each other. For instance, there's constructive interference where the ridge of one wave meets the ridge of another, then it makes it higher. And where a trough meets a trough, it makes it deeper. And there's destructive interference, that when a ridge meets a trough, there it will be level, and they cancel each other out. So the point is, when waves come through two inlets, they will create what's called an interference pattern. Now, Thomas Young, being smart, thought, well, if light is a wave, then let's see what happens. When we have a light source, we shine it through two slits, and let's see what comes of it. And you can do this for yourself. I actually had it all set up and was shining on the wall behind me using a laser with two slits, which I have on a slide. And it creates an interference pattern. You can see this band, in this case, the bands of light, there's a lot of horizontal ones. And so he did this with light and got his interference pattern. So therefore, light must be a wave. Matter sorted, decided, at least for the 19th century. But then in the early 20th century, physics changed. And some cute physicists thought, well, let's try the same experiment with electrons. Now, if you have an electron source and it's pumping out a stream of electrons, and you send them through a single slit, then what you get is one kind of bar like that. And there's a little bit of spreading out because it's of diffraction and perhaps bouncing off the slit. But there's no interference pattern, obviously, because it's just whatever is the start of this is coming through. And that's what you would expect. This pattern is what you would expect, whether light is a wave or whether the electron is behaving as a wave or whether it's acting as a particle. You would, with one slit, you would get one kind of bar of light. Now, send the same set of electrons towards a double slit. And what you would expect to get is two bars, because if these electrons are particles, they would go, some of them would go through the left, some would go through the right. They'd form two kind of similar bars of light on our screen. That's what you would expect, but that's not what happens. Instead, when you send the electrons through the two slits, you get an interference pattern. Now, could this, this was shocking in one sense, because it meant that the electron, which everyone has been thinking of as a particle, it's an object, a thing, is now actually a wave. Now this is weird, that it's behaving as a wave through the slits. Now, someone argued, well, maybe it's just that these particle of electrons are just jostling with each other and trying to get through the slits, and it just ends up making this type of pattern. But you can be really crafty. You can actually set this experiment up and send each electron through one at a time. So bleep, an electron goes, bleep, and it goes through, it passes through the slits, and it hits the screen and creates what's called a scintillation spot. So here is the beginning of that experiment. You're getting the electrons are hitting the screen in different places. Now that's probably no surprise so far. Okay, the electron is going through. So this doesn't tell us very much yet. But then you get a few more. Then you get a few more. Now there's something starting to happen here. And by the time you finish, you actually start to see there's an interference pattern. Now this is really weird, because this means that our electron, one at a time, has decided to find its place within certain bands on the screen. Not others, but certain bands. And it's finding its place on the basis that as a wave it has passed through these two slits simultaneously, and therefore has to find its place on the screen. So really what has happened is that the electron has proceeded from source through both slits as a wave and until it hits the screen. And the screen acts as a detector, because the screen demands that the wave tells us there's something more about itself. So the electrons are setting off as a wave, They don't have any particular location, nor do they have to follow a particular path. This single object is passing through both slits simultaneously. And it's not being broken up or divided up or anything. It's passing through both slits simultaneously. And it continues as a wave all the way to the screen. And it can do that in its wave state with no requirement to manifest particle properties. And if there was no screen, it would continue to be a wave. But when we set up the screen that the wave is going to hit and impact, then the screen requires the object to decide. And we use that kind of anthropomorphically, to decide its location. As a wave, the location of the electron just before reaching that was kind of spread out across the length of the screen. But because the screen interacts with that wave and demands a particle type property, now the electron has to decide where it should appear. But it does so according to a set of probabilities for where it may be found. And note that we say where the probabilities of the quantum state are, say, where it can be found, not where it is. Now, this principle of sending one object through and creating interference patterns doesn't just apply to very small stuff like photons and electrons, but actually to much bigger things. Obviously, protons, neutrons, atoms, even molecules, even objects up to 800 or so atoms. They can do this. Not a cat yet, but I'm sure there's those who are still trying. So physicists get inventive, and they've all sorts of variations on this experiment. We haven't time to talk about them all. Let's just look at the important one. If we set up a detector after the slit, after just one of these slits, and we're going to look at, is something passing through this slit? Is there an actual electron going through this slit? Then what happens, without that detector necessarily interfering with the path or the physicality of the electron wave, still the interference pattern disappears. It just doesn't, it's not there. So somehow or other, because the detector is trying to extract information about the state of the electron as it comes out of the slit, that the wave that had proceeded to that point and possibly through the slits then is now deciding, actually, I went through the slit as a particle, either in this one, the left-hand one, or the right-hand one. Now, this is the kind of weirdness that is at the heart of the quantum phenomena. That as soon as we leave it alone, each individual electron's happy to be a wave. As soon as we raise a question of where it is or what path it took, then the electron has to respond to our setup and present us with its particle properties, showing its location and path. Now, let's just think about this a little bit more, because this is starting to get kind of weird. And I'm going to share a way of visualizing this issue using a kind of these diagrams which were given to me by the professor of physics at Dublin Institute of Technology. And he offered it like this. He said, you can picture a quantum object like this as two dots within a bracket. Now this could represent an electron, a photon, an atom, or whatever. And when it's shown in the bracket like this, we are suggesting that the object is in its probability state, meaning that it's got these two dots, and it shows us that the object has the potential to manifest either as red or blue. Now, electron hasn't got color, so I'm just using red and blue as a way of visualizing properties. So in the probability state, we don't know anything about the this object other than it has the potential to manifest as red or the potential to manifest as blue. And you might say, yeah, but I want to know, which is it? Is it red or is it blue? And as soon as we set that question and have some way of getting that information and seeing whether it is red or blue, as soon as we confront that object, which is in its quantum probability state, it responds by giving us an answer. Now, we cannot, at this stage, we're saying we don't know which answer that will be. That's up to the object and its probability. But in this case, the quantum wave state collapses and the object manifests a specific particle property. In this case, redness. It's showing it's red. Now, I'm just going to note that there's objection sometimes to the use of the term collapse of the wave function, because there's lots of new ways of thinking about what is actually happening. However, you'll find that pretty well all physicists still use that phrase, because as yet there's no better commonly accepted phrase that's been established. So excuse me if I use it. We're saying that there's some collapse of the probability state into the specifics of the particle, showing us observable properties. In this case, that it is a red object. So it can be said that the physical stuff responds to our examination of it. It presents property aspects of itself that relate to the nature of our inquiry. So it therefore could be asked if the reality of the physical world is to some degree consciousness dependent. Now, this is another debating point. Exactly how does consciousness of the observer fit in? What is measurement? What is observation? How does all this thing works? And it's a fascinating, but it's a very complicated question. I'm not going to deal with it here, but it deserves deeper attention in another talk. So in part 4, we will explore this. It's been a huge debate for the last 100 years, but the big problem in trying to resolve this question, I would suggest, has been a lack of understanding of what we mean by consciousness or the observer. When you haven't got that clarified, how are you going to understand how consciousness involves itself in quantum mechanics? And another thing, if you don't know how consciousness and psychological intention can be embedded within the physicality of the world within your systems, then you also will not be able to understand at what level information is being extracted and demanded from a quantum particle, a quantum object rather. So I personally believe that the Sankhya and Vedanta model, which we're giving here in the Atma Paradigm, can really help explore these questions. I think we've got a unique take on it, and as I say, we'll present this in part 4. But the key thing is, we don't need to resolve that question. I'm not making some simplistic thing that consciousness drives and determines the whole of quantum physics. I'm not making a simplistic statement like that. Certainly these experiments question the nature of reality and question that we cannot just blindly assume that there is what is called naive reality, that there is an absolutely objective world. When we know that objects are now presenting properties to us because we have demanded certain information from them, that means that somehow or other there is some relationship between our intention, our awareness, our consciousness in some way, whether it's personal or whether it's subliminal, whether it is more a kind of widespread field of consciousness. There is some kind of interaction that it is being represented and affecting the way the physical world presents itself to us. So, big topic for another time. But what we can say from the double slit experiment is, in terms of the question we ask and how we set up the measurement system, that represents our intention, and that produces a change in the physical reality of an object. And it does so without any change in the overall energy of the system. So this looks like that consciousness or intention might have a way of affecting the properties and behavior of physical stuff without interruption of the conservation of energy. Now, this is all, in one sense, can be taken as theory, but is there any experimental evidence to support the idea that thoughts and intention alone can produce real physical effects? Can psychological stuff like thoughts or emotions affect physical things? Now, this was a question that intrigued James McDonald in the 1970s. James McDonald was one of the two guys behind the McDonnell Douglas aircraft corporation. So these guys, built DC-10s and helicopters and all sorts of things. And he was worried that if consciousness or intention or emotions might affect, physical sensitive systems like the electronics we have in an airplane, that could be rather dangerous. We need to kind of think about what that sort of interaction would be. So MacDonald approached his friend Robert John, who was the then dean of the engineering department at Princeton University. And together they conceived of a program that would test this kind of question. Can intention affect physical systems? So from that was set up a specific research project, which was called Princeton Engineering Anomalous Research, often shortened just to its acronym PAIR. Okay, and this was a program that ran for 27 years, from 79 to 2007. Its objectives were to study the interaction of human consciousness with sensitive devices, systems, and processes. So that was its primary purpose. And then, having done that, to develop complementary theoretical models to enable a better understanding of the role of consciousness in the establishment of physical reality. Now, the key experiments were being done using a random event generator. Now, there's different types of REGs that you can get. You can get an app on your phone that produces kind of random numbers, but it's using an algorithm. That's not pure randomness in one sense. And that sort of random event generator is not suitable for PAIR's purpose. So they constructed their own. It was a quantum-based REG that exploited the phenomenon of quantum tunneling. Let me explain what quantum tunneling is. Now, this is a situation where we've got a constant source of electrons and it's being fired along this wire, this yellow wire. Okay, so the red dot represents one of the electrons. Okay, now it comes up to a negatively charged barrier. And electrons are negative, therefore they're not going to like a negative charge barrier, they're going to be repelled. And that's the case for most of them. However, some of those electrons, and again we use the word loosely, choose to exhibit a non-particle, a wave state property. Now in the wave state, they are not troubled by the negatively charged barrier, and they just pass through. And they continue on their route to the REG counter on the right-hand side. Now, only a small percentage of the original flow of electrons gets through. So you can calibrate your machine and see how many, what is the normal percentage of electrons that will get through and tunnel in this way. And you can plot it on a graph and you create a kind of baseline. And here it is in this yellow line shown here. It's a little ragged. It kind of goes up and down a little bit because that's randomness. But eventually, kind of, if you do it long enough, you're going to get it, evening out as along the base. So that is the baseline. And what the PAIR experiments tried to do was to get subjects to change the output. So instead of it just bouncing along the baseline, they tried to get subjects and they told them, your job is your job is to raise this line, get it going along the red direction. And in others, they got them to make it go lower and lower the output. So what they were effectively doing is that they were trying to get people just through their intention, just to will the machine and will the output to go up or to will it to go down. And effectively, what was happening is their intention had to have an impact on the number of electrons passing through that barrier. So effectively, raising it means that you're telling more electrons, I need you to go quantum, get through here. And with the trying to lower it and follow the blue line, you're telling the electrons, no, just stay as a particle, it'll be all right. Don't worry about it, just stay as a particle, don't go through. Now, in real terms, of course, the subjects weren't meditating on the individual electrons and having a conversation with them. They were simply just sending out the general intention that I want this line to go up. I want this line to go up. And those who were able to kind of resonate or kind of feel some kind of connection, if you like, with the equipment seemed to do it well. So here's the results for 120,000 trials for those trying to raise the output. And they're plotted together. Now, if they were simply just by chance, they would have followed the sort of green line along the bottom, bouncing around and ending up pretty well level. But no, although they went up and down, because some people trying to will the line to go up, it went down for them. Some people didn't get it to do anything. But everyone was counted. Every trial was counted. So after 120 trials, there is a very serious deflection. It should be noted for those who like these things that the kind of curved line above and below represents the 2 sigma area. So anything within that is just of 2 sigma significance. And when it's getting up there, you're getting into very serious 5 sigma territory. On the one going down, here's 120 trials trying to make it go down. There was again a very serious deflection, not quite as strong as the one going up. Now, what Pear did was to accumulate all these results statistically, and there was a total of, the total was over 800,000 trials. And the deflection from what could be obtained by chance represented odds of 1 in 3 billion. That's huge statistical significance. Even if you divide it by 1,000, you know, you're in 5 sigma territory, 1 in 3.3 million, which is often considered a pretty solid standard for claiming that you have some scientific proof. So the Pear conclusions were that human consciousness can affect physical systems, including electronic and even mechanical random event machines. And here I show Robert John and Brenda Dunn, who was his manager of the lab throughout all the time. And they're in front of the mechanical cascade that they had, where, and I think they've shown this photograph because it's quite significant, that the balls falling through the system have deviated rather. They've deviated from the normal curve that would be expected. So they had subjects sitting there trying to will them to go that. So here is human consciousness operating on some physical objects like these ball bearings, but our interest at the moment is that they found that human consciousness can affect physical systems, including quantum-based electronic machines. And just as further observations, the results were not dependent on proximity or time. That's something we'll get into a little later. And the tests indicate greater effect through shared or heightened emotion and intention. And that will be a subject, that will be an important point that we will explore when we get to life. Now, where does that take us? So this establishes the evidence that intention can indeed affect quantum processes, which in turn affect physical things. So reality can be said to be manipulated by intention. Now, does this help us with our question about thoughts and intention interacting with the brain? And then the answer is yes, if there are quantum processes happening in the brain, then it could help us. So that takes us to our third point, quantum-based systems within biology. So, are there quantum-based processes in biological systems like the brain? And that used to be a reasonable question, because until recently it was assumed that biology is kind of warm and wet and not at all suitable for quantum objects to retain their quantum or probability state. There's so much going on in live organic stuff, even in the cabbage, that they weren't considered hospitable to the quantum world. However, that idea has gone. Now we're seeing more and more examples of how nature utilizes quantum effects. And I'm just going to give you one, which is a real important example used throughout nature. even in a cabbage. It's photosynthesis. Photosynthesis used by all plants, even algae, and even some microorganisms. It is the process for turning carbon dioxide and water into useful sugars for the plants, and of course releasing useful oxygen for us. So we know that this is the thing that sustains all life on Earth. Now, the key issue is that it relies on a ray of sunlight, a photon, interacting with what's called the reaction center. And this reaction center is just that one area which can actually initiate the photosynthesis process. But the reaction center is hidden in amidst of, innumerable chlorophyll molecules. And that photon is hitting one of those molecules. And when it hits a molecule, it excites an electron there. And that electron is then called an exciton. And it trots off to try and find the reaction center. So off it goes bouncing from one cell to another. Now, if it actually goes as a particle, it has to go from one cell to the next, to the next, to the next, to the next, and so on. And maybe it'll never find the reaction center because each step along the way it's losing energy. So even if it does get to the reaction center, it may not be able to do anything. And if that was the process that was at work, probably photosynthesis would never happen. Certainly not regularly enough to create the world and the ecosystems that we know and love. So the understanding is that when that photon hits the electron and creates the exciton, then that exciton actually becomes a wave. In one sense, you can say it travels everywhere, but it exists throughout the range of these molecules all at the same time. You could say it can explore all possible paths and take the most effective, or more correctly, probably it is now present everywhere. It is non-local, and when it is in the presence of the reaction center, it instantaneously collapses itself as an excited particle. And at that point, then photosynthesis process it works. So in this system, by going quantum, the exciton does not get lost and it doesn't lose energy. And photosynthesis happens, thank God. And that we're all able to enjoy the benefits of it. So my point in giving you this example, and there are many, many more that are starting to crop up, is that biology is a home for quantum activity. And if a cabbage can do it, then perhaps so can our brains. And now we're on to our fourth point, that non-neural intention can affect brain activity by exploiting quantum processes within the neurons. Now, a few years ago, our group, the Science and Philosophy Initiative, invited Stuart Hameroff to give a lecture at the physics department at Oxford University. Stuart Hameroff is an anesthesiologist and also professor at the University of Arizona. He's also the lead organizer of the annual Science of Consciousness conference. And here he is on the night that we took them out for a pizza with Roger Penrose. We walked past the Maths department. So Rog wanted to show us the special tiling that he had designed. So in Hameroff's lecture there at Oxford, he presented the system he had worked on with Penrose called ORC-OR, Orchestrated Objective Reduction. And then the next day I got to spend the morning with Stuart to examine his work and theories. Now, it was clear that he had evidence of quantum-based activity that directly impacts the firing of our neurons. This is fascinating stuff. But it's a little technical and we're into a bit of neuroscience. But I managed to get it from how Stuart explained it to me, and I'm sure you will too. Here's a diagram of a typical brain neuron. The two bits that I want to focus on, one is in red, that's the axon. This is the long tail that connects this brain with other neurons. And you can see just below it, I've labeled direction of information. So we want information to flow from the large nucleus-based area of the main kind of area of the cell along the axon, so that it can go through those little arms at the end and connect with other neurons. And the other thing that is not so well kind of discussed in kind of A-level biology or something are these orange kind of little kind of worm things. They're microtubules. Okay. Now these are, there's so many. They're basically the structure of the inside of the neuron, and these are tubular cells which carry and convey chemical messages to and fro. So they're picking up information from the dendrites and they're sending it up into the center of the cell. Now let's focus in a little with a close-up. So we need the neuron to fire, and to fire it has to get a positive electrical charge to pass up the axon towards the neighboring neurons. So here it is, positive charge is building up on the outside of the cell, but it doesn't just pass along whenever it likes. There is a thing called the axon hillock, which basically is a barrier which holds back the charge, and neurons either fire or they don't fire. So here it's got a charge, but it's not firing. So now you would think the question of whether the neuron fires is all to do with this axon hillock and its threshold for letting the charge through. Now you would think that that threshold must be fixed in some way, but it isn't. It actually is kind of variable. Now the question is, what does the varying of that threshold? Because the varying will say whether it fires or not. Now, what Hameroff and Penrose have analysed is how there is an accumulation of signals which are separate from the charge, but they're coming from the microtubules. And inside the microtubules, there is the potential for quantum state objects collapsing. And if they collapse, then there will be signals sent to the axon hillock. That means that there are quantum processes within those microtubules which send out an effect which then varies the threshold of the axon hillock and allows the charge to pass through and the neuron to fire. So this kind of indicates that the firing of your brain cells is dependent on quantum processes within each neuron. Now, Hameroff and Penrose's ideas are contentious, but it's because they have other aspects of their theory that claims that the collapse of the quantum state produces consciousness. And that is a claim, I believe, that's too far. And I actually raised the question with Hameroff how that worked, and that's the bit that's not worked out. But what he has got is that he has shown that it is feasible that the firing of our brain cells could be affected or influenced or even determined by quantum processes. And this raises the point that we are making, that maybe, and those quantum processes are themselves being controlled. And it certainly provides a route by which your thoughts might be able to vary the behavior of the quantum processes, which then vary the behavior, send messages to the axon hillock, which then changes how that neuron fires. So perhaps there is an opportunity here for intention to interact with individual or groups of neurons and create and control the firing that goes on inside your brain. So, as I said, I did challenge Hameroff about his theory because it fails to address non-physical qualia and other aspects. But I'm suggesting that rather than using Or as a claim for consciousness, a less ambitious claim for his work might be that it demonstrates the potential for non-neural intention to interact with quantum processes happening within the neuron and thereby affect, influence, maybe even control the firing. of our neurons. So, and I'm not saying this is the only possible route that's been suggested, and actually others have suggested, for instance, there seems to be variability in how the ligands or the carrying messages across the synapses make connections with their receptors. Others have suggested that there may be a variability there, which is subject to psychological manipulation, if you like, intention. So even if one questions these routes as being absolute definite, what I'm suggesting is what we got here are possibilities for serious research. And I suggest to neuroscientists that you are far more likely to have success identifying specific routes for non-neural consciousness to interact with the brain than you are of ever finding an actual cause or source of consciousness within the brain. So we come to our final kind of point, that these effects on the quantum scale of a single quantum particle might seem to be very, very small. But that is all it takes for things to start happening. And our final point today is that these tiny inputs can be magnified into macro scale effects using the existing flow of energy within a system. And Hamarov made that point to me. I was questioning him, well, how does this, I just put the general question to him, how does this affect the conservation of energy? And he says, the brain has tons of energy. And we know that. 20% of your blood is pumping oxygen to it. It works at around 15 watts. Your brain is full of energy. It's just a question of how those energy are used. And affecting the quantum states, affecting the firing of the neurons, does not create energy. It does not destroy energy. It is neutral in terms of the conservation of energy. So that sort of claim against the idea that non-neural consciousness could possibly make changes in physicality is actually a dead duck. Now let's look at these tiny things. So how tiny things can affect macro things. And you can't get much more macro in this world than a big hydroelectric dam. Here you go. Now, you know how it works. There's a reservoir at the top and there's a big drop down to the bottom. And when you've got something at a high level and it can fall to the bottom, then you've got potential energy. And it cascades down. But when it cascades, like in the picture, nothing's being used in that. That's just water pouring down and the energy is basically gone. So within a hydroelectric dam, you're not using the cascade, but you're going to take some of it. And you're going to direct some of that water. Instead of letting it flow over the top, you're going to send it down what's called a penstock, a kind of bypass route. And you can see my little diagram has now got a kind of little arm to the right, representing that. So you want to send it down there, and at the bottom of that, you're going to have your turbine, because that water will rush down there with huge pressure behind it. And that is so useful for extracting and turning that potential energy into mechanical energy to turn the turbine, and then to use the mechanical energy to turn into electrical energy and power the local town. So this run of water leads to the turbine. At the moment that there's a sluice gate and it's closed. So no water is passing down to our turbine. You can see at the center of our diagram, we've got the sluice gate, and it kind of is one of these swivel things. So it can be up in the closed position. Now the opening and shutting movement of the sluice gate runs on electricity or whatever. And that may itself come from the power station. And the movement of the sluice gate is controlled by perhaps one little dial, or probably these days a click on the screen or a tap on a tablet. And here we have our little dial. It's set at 0. But we have the intention to get some work out of this power station. And so we want to divert some of the water. We want to change reality. We want to convert the potential energy of the water flowing down into getting some work out of it and making some electricity. So all we have to do is turn that dial from 0, say, to 3. and the gate starts to open. And when it's open, the water flows down to the turbine and it starts to turn. So we could now be producing enough electricity to run a whole city on the basis of that tiny little change. So all it requires intention to do is to be able to vary the input and vary the input by changing the information used within the system itself. But the system uses its own energy, and a huge, very large effect can be done. So, a kind of summary for today, that process that we just described works because the physical energy of the waterfall already exists. We are simply converting one type of physical energy into a different form of physical energy. And that's really the way this world works. And we're going to look at our future aspects of life and the universe in terms of this principle, that energy is simply being converted, but from one type into another. And the way a system uses and converts energy is controlled by information. So information determines how a system uses and converts its energy. Just like the information on this dial, whether it's 0 or 3, changes how that hydroelectric dam and power station converts its energy. And intention is the impetus to vary that information. So we're now looking at it slightly different. Now, you might argue that information might change by chance. Maybe. But we certainly know that I, as a conscious being, am a source of intentional information. I want to do things. Now, I don't need to provide the energy for the power station. I don't need to provide the energy for the sluice gate. I just need to do enough to vary the information to exploit the energy already within the system. And that's what we have shown with the processes in the brain. That non-neural intention has the ability to affect enough of a change within the quantum states in the neurons in order to determine whether those neurons fire or not. So in this way, thoughts have become physical reality. And we've shown that that can happen without contravention of any of the laws of physics. So this idea that will we have to rewrite physics? Do we have to rewrite all the textbooks if consciousness is non-neural? No, that's a red herring. You just have to understand how the process of information works. And so I think we have addressed the 3 questions that we set ourselves. We've gone through an awful lot very quickly. They've been complex, but I hope that you've kind of got an idea, which will be a starting point, and these will be further developed as we go along. So, yes, our thoughts and desires can and do have agency. There are possible routes by which non-neural thoughts could give rise to biological processes in the brain and initiate neural activity. And we've explored how this could be done, as I say, without contravention of physics. And so we can say that will, arising from the conscious entity, the Atma, and then developed as non-neural intention, can produce the effects of action and manifestation within physical reality. And next week, we intend to develop these ideas much further as we explore information as a fundamental feature that underpins the world as we know it. Now, you see the question and answer little logo. I should have drawn your attention maybe perhaps earlier, but if you've got a question, please put it down, and we've got a couple of minutes. We can just take a little something. So let me just see what we have. Is the quantum influence of the firing of our neurons the influence of the non-neural mind, or some other force beyond ourselves? That is a question that we have to leave open here, but the task that we set ourselves, was it possible that non-neural mind, our own, could have the potential for interacting with the brain in order to produce the neural activity that would control our body. Now, not all of our bodily functions are controlled consciously. We're not saying that, but where we might need to or where we may want to, then at least that route is possible. So really what we're establishing here today is that the principle of non-neural, non-physical consciousness interacting with through the non-neural mind producing intention can also interact and inject information into physical systems, whether they're biological, like the brain, or whether they're electronic or quantum-based. So there is opportunity for us to affect reality. And how that happens, that will be the subject for our discussion next week. And I'd like to close it. It's now exactly 7 o'clock or just after. But thank you very much. We are next week going to look at information as reality. These are the principles of technologies for manipulating matter. And that will complete part 2 of our 4-part series. Then there's going to be a 1-week gap, and I'm just giving you a little prior notice. So no talk on the 13th. We'll hear next week to complete part 2, but on the 13th, no talk. It's not because I'm superstitious about 13th or going on holiday. It's a special time for many of us, and we're otherwise intentionally occupied in other ways. But we'll be back in action on Thursday, the 20th of August for the start of part 3 on life. But next week, we're here. Information is reality. There's some really interesting stuff within that I think you'll find fascinating. See you next week. Hare Krishna.